In this video, I'm going to show how I make the shaker style door. Sometimes it's called tongue and groove or rail and styles or mission style door. It's a pretty simple and elegant door. It has two rails and two styles. So the rails are the top and bottom, and the styles are the left and right pieces of wood. And in the middle, there's a plywood panel. The main tool I'm going to be using is this Freud tongue and groove bit. It's the 99036 adjustable tongue and groove bit. This being the tongue and this is the groove. And this is for the tongue and this is for the groove. What it comes with is these set of washers. And they come in various thickness, very precise thickness. These washers can be removed and they need to be put in between these blades to make the blade fatter or thicker. And the idea is the washer that I would choose for tongue will most likely be the same thickness washer that I'll choose for the groove. And it comes with this table that can be referenced. So I'm using a 1/4 inch plywood. I probably will be using this 0.008 thick. And I'll try that out and see if it works. 1/4 inch plywood is rarely ever really 1/4 inch. So based on my plywood, I can maybe use 0.008 or maybe add a washer or remove one. I'll have to check that out. The only issue I saw is that these washers, they don't have any markings on them, so I don't know what thickness it is, and it becomes very difficult to just to guess. So just to be sure, I use my digital calipers that tells me exactly what. So this one is 0.06, I know. So I'm going to be using this to build my shaker doors. I'm going to go over the measurements and the theory behind shaker style doors. Shaker style doors are very simple, 4 pieces of wood and a plywood panel or a solid wood panel in between. I'm going to use a plywood panel in my sample door. The top and the bottom pieces are called rails and the left and right pieces are called styles. The styles have grooves in them and the rails have tongues, basically protrusions. The length of the depth of the groove or the depth of the tongue is dictated by the router bit. Different router bits might have different depths, but in my case it makes a tongue that is 7/16 of an inch wide, or it makes a groove that is also 7/16 of an inch wide. So overall, if the length of the door is known, then it's pretty easy to calculate what size rail we need, because it's going to be the overall desired length of the door. Then it's going to be whatever that length is minus twice the width of the stiles on this end and this end, plus the tongue, the depth of the tongue, the length of the tongue, which is going to be 7/16 in my case. And so 2 7/16 for this end and this end. So that's the size of the rail that I'm going to be cutting. The size of the style will be obviously the overall height of the door itself. So that's not an issue over there. This particular figure is also the same shaker style door, but I'm showing the plywood panel in between. So I'm going to be using a 1/4 inch plywood panel here. The plywood panel also goes into the groove. So the grooves are made all over, and the style on the rail, on this style and this rail, either this rail too. So all 4 sides have grooves, and the plywood panel basically fits and goes into the groove. Now to understand what's the dimensions of the plywood panel that I need to cut, it's pretty straightforward too. It's going to be the overall length of the door minus twice the width of these left and right styles, and plus whatever excess I need to put this into the groove. The same thing for the plywood height. It's going to be the overall height of the door minus twice the width of these 2 rails plus the excess that I'm going to be using. And the excess, logically thinking, should be 7/16 of an inch, because that's the excess I get with the router bit. But it's very difficult to get an exact plywood panel dimensions like that. Sometimes there could be issues where it's too big or too loose, and it might just move around with some pressure, or it might move around due to seasonal changes, etc. So I'm going to use a different approach here. I'm not going to be cutting it exactly 7/16 of an excess, but a different excess, which I'm going to be explaining. To explain that, I'm going to be looking at my router penetration. So I know my router bit penetration is 7/16 of an inch. And what I'm going to be using is space balls, and I'll show you that in a bit. These are little balls that are compressible, and they are 1/4 of an inch in diameter. So I know that if I have 7/16 of an inch, if I put 1/4 of an inch, if I go in 1/4 of an inch with my plywood panel, then what I'll be left with is 3/16 of an inch, which is exactly what I want. It's because these space balls, they are compressible, like I said, and they compress to I would probably want it to compress to 3/16 of an inch. So 3/16 of an inch from the space ball plus my desired penetration of 1/4 of an inch will give me 7/16 of an inch. That's on one side. So if I take the 1/4 of an inch excess on the left and the right, or the top and the bottom, then I have 1/2 an inch of excess. And that's the excess that I'm going to be putting over here. So that's the excess, 1/2 an inch excess that I'm going to be putting when I cut the plywood. The last thing to note is that if you noticed in my explanation, the groove that is going to be in this style is going to be accommodating both the plywood panel and the rail. So it will be easier if I have the width of the groove, if I keep it same for both the plywood panel and the rail. So what I'm going to start with is first cut the groove to match the width exactly to the plywood panel. I'm going to be using 1/4 of an inch plywood panel, but 1/4 inch is rarely ever 1/4 inch in plywood world. So I'm going to make sure that I adjust my groove to make sure first that my plywood panel fits in, and then later I'm going to adjust the tongue of the rail to match the width of the plywood panel, so I can use the same groove from top to bottom for both the rails and the plywood panel in between. These are the space balls, compressible space balls, 1/4 of an inch. Before we adjust the height of the router bit and the depth from the fence, the router bit itself needs to be understood, the operation of it. So what it comes with is the nut on the top, and there are several of these height adjustment washers, and they are different thicknesses. So all of that comes out. There's a bearing, and then you have two cutters, and that's the same logic applies to both the tongue and the groove bit. There are two cutters, and between the two cutters, this is the top cutter and this is the bottom cutter, between the two cutters the adjustment washers go in. So I have two of these adjustment washers here. Like I said before, the plywood thickness that is being used is not, even though I'm using a 1/4 inch plywood, it's never really 1/4 inch. So even though my table over here says that I need to use 0.008, that's just one washer for 1/4 inch, I found that wasn't enough. So I had to use two washers, one 0.008 and one 0.006. So I had to use two washers to get the right thickness for this bit. So I put these washers in here and I put the bit on top of it. And I think one critical thing important for both this groove bit as well as the tongue bit is to make sure that the blade orientation is same. If I accidentally put it upside down, that's going to mess up the measurements. So the blades have to be put as per factory recommendation, as per the user manual. They have to be on the right side up to work. And that's how both the tongue and the groove is set up. I'm going to put back my bearing and the washer, and then put the nut on and tighten it, and that's it. When the thickness of this groove is done correctly, this is how the cut looks like. This is my test cut. This is my plywood that goes in, the middle plywood panel, and it should go in pretty nicely, snugly, not too tight, not too loose. Need a couple of tabs. It should go in with a couple of tabs, like this, like this. Before I start using my router bit, it's a good time to start prepping the wood, in the sense marking the wood. I need to know which side is going to be the front of the door versus the back, and I'm going to mark that exactly. This is going to be my top wood, this is going to be my left and right, and this is going to be my bottom with the arrow mark indicating the outside edge. I also mark my plywood. I know this is going to be my front face, and this is going to be the aligning towards the top of the door. The groove cuts are the first cuts that I'm going to make. So after I have adjusted the thickness of the groove router bit to match the thickness of the plywood, now I'm going to adjust the router bit with respect to the table. And there are two major adjustments that is to be made. First one is the height of the blade from the router table. So I'm using my 1/4 inch gauge bar to adjust the router bit so that the lower corner of the lower cutter, not the upper cutter, because this bit has two cutters, but the lower corner of the lower cutter is 1/4 of an inch from top of the router table. And I make sure that I'm not measuring from the red part, but from the metal of the router table, the metal platform of the router table. And I adjust it so that it barely touches the lower corner of the lower cutter. The second adjustment is how far the fence is. The fence has to be aligned with the edge of this bearing. So again, I take my gauge bar and basically align the fence to make sure it's in alignment with this bearing. And that's it. There's my groove cuts on the inside of all 4 sides of the door. The next step is to make the tongue, and the tongues are made only on the rails. That means the top and bottom. To make the tongue cut, these are the adjustments I'm going to make. I already put the tongue bit in, and my previous assumption was that I would be using the same exact thickness and amount of washers that I used for the groove in this bit. But I guess I was wrong. I made a few test cuts. I had to put in more washers in to fit to make the tongue as wide for the groove. So you can see here, I'm taking the extra washers out from the top, and I put a couple of more washers in to make my tongue fit into the grooves that I already made before I showed. So what I did is I put in the washers I need. I already did some test cut. In order to make sure that everything fits before I do my final cut, what I did is took the groove that I cut, the final groove cut that I had made before on one of these tiles. This is one of these tiles. And then I took a scrap plywood to make a test cut for the tongue on the scrap plywood first. And I made sure that the scrap plywood fits properly on my real style. That is the actual style that I'm going to be using for the door, not the scrap style. Once I have that, that means I know that my thickness is correct and my number of washers are correct. Then I'm going to start cutting the actual tongues on the rails that I need to be cutting. So again, scrap plywood tongue on the real style groove. So this is how I adjusted the router table against the router bit. The first thing, I did not adjust the router table fence. The router table fence is in the exact position what it was for the groove cut. And I think during the real cuts, it's always good to make all the groove cuts together, change out the bit to the tongue bit, and then do all the tongue cuts. That way, the depth of the cut for the groove and the depth of the cut for the tongue, which obviously is dependent upon the router fence position, will remain exactly the same. Next is the adjustment for the height of the bit, and again I took my 1/4 inch gauge bar and made sure that the tip of the lower cutter, not the upper cutter, but the tip of the lower cutter, to be precise, the upper tip of the lower cutter is in line and flush with my 1/4 inch gauge bar surface. So I'm making sure that my cut, the lower cut, is 1/4 inch above my router table. So I'm going to be making the cuts now. I'm going to be using my coping sled jig that I made. I'll post a separate video about how I made that jig later on. So here's my tongue cuts for the top rail on both sides and the bottom rail on both sides. One of the things to remember is when making the cuts, the front side of the door or the marked side of the door is always on the top like this and not upside down. That will mess up the measurements, because we're always measuring 1/4 of an inch for both the groove and the tongue. We're always measuring 1/4 of an inch from the router table, which is from the back side of the door. So it needs to go like this with the top side up. The other thing is these tongues are, like I said before, 7/16 of an inch, and that is determined by the distance of the tip of the blade to the bearing in both the groove and the tongue bits. For this particular brand of router bit, the Freud, it's 7/16 of an inch. So other brands could be 3/8 of an inch sometimes, but I need to know what is the depth. So that depth is 7/16 of an inch, and that is what is reflected in this tongue, which is usually 7/16 of an inch. It's also reflected in the groove, which is 7/16 of an inch deep, and that way they fit together properly. Next, I'm gonna put this panel in now, and time to glue. Before I glue, I might sand it, just because it's not possible to sand as good after we glue. And when I glue it, I'm going to use my space balls here. I'm going to put 2 on each of these 4 parts, so maybe 2 on each side closer to the corner over here, 1 here, 1 here. So 8 in total for the whole door. So here's my finished plywood. That's the front, and that's the back. It's all sanded down. So I'm going to give some of my closing thoughts. Most people, when they use this router bit or use this method, they do the tongue cut first before the groove. But I did the other way around. And the reason for that was, like I mentioned before, I wanted to use the same groove width for both the plywood as well as the top and the bottom rail. That made it easier for me. So I did the groove first, and then I did the adjusted my rail tongue to fit that groove. The way I adjusted it was using this 1/4 inch bar. By adjusting the level of the uh, bar with the tip of the blade. That works, that should work. Sometimes it might result in not perfect fitting. There could be some, it may not be flush as you want, but it can be easily sanded down. But I think in addition to this, using this bar, what can be done is I could cut some additional scrap grooves using the final groove length that I determined before. So in addition to my grooves that I made to my final pieces, I also made the same grooves to some scrap wood. And later on, I use this scrap wood to run through my tongue. And if I get any such shavings, thin shavings are fine, I guess, but any thick shavings, that will tell me that my bit height is not proper. So the bit height may have to be adjusted slightly. But all in all, I think it works. If there are any sort of up and down sort of fitting that is not flush, sometimes it's due to the nature of the wood itself, and this is very low quality wood. But most of it can be sanded down. It's not a big deal. The last thing to note is that these doors are obviously essentially going to be either stained or painted, and these corners or the edges are very sharp. So it's always a good idea to basically sand them down lightly to make it not as sharp, but just make it as slightly rounded on the edges using a sandpaper. Just maybe 3 or 4 sort of wipes with a sandpaper using 80 or 100 grit. That makes it not sharp, and that allows the stain or the paint to stick and absorb properly. So that's it. Thank you for watching.